Okay, so we're going to start with surface area and volume. Just a quick overview. If you got an orange and you want to think about the volume, it's how much is in, or how much space it takes up. That's going to be the volume. Surface area is a little bit weirder because it's not totally flat, like area. Instead, you'd think about, okay, so this is an orange. If I peeled off the outside and I just stuck it flat, and you found the area of that would be the surface area, okay? The other thing that we get is when you split this, you're gonna create cross sections. So here, you don't wanna split it somewhere like here. You wanna split it directly in the middle here. That way, you have the biggest circle in the middle, because the circle here is gonna be bigger than if you cut it here. Okay, now that circle, when you end up looking at it and it's a flat circle, that circle in the middle is called the great circle. So that's what they mean by the terminology in the instructions. So let's get into the practice problems. It says find the volume. First we need our formula. So this is a sphere. Our volume for a sphere is volume equals 4/3 pi radius cubed. Now, we haven't really worked with cubed that much. For example, we know squared. So if this was like 3 squared, that's equal to 3 times 3. So 3 cubed is equal to 3 times 3 times 3. You just multiply it one more time by the original number, okay? So I look at this. Right now I have 33 centimeters, and that's the diameter. So I have diameter equals 33. To get the radius, we want half of it. So radius is equal to this divided by 2, which is going to give us 16.5. Now let me just plug it in. Right there. I get volume equals 4/3 pi times 16.5 cubed. Okay? Go to your, if you want, I know some of you have graphing calculators. If you have the graphing calculator, you just hit the one that says x cubed. It's the same thing in this case for the actual foam calculator. So you want to take that foam and you want to turn it sideways so that all the other little numbers come up for it. And that's where you should be able to find this. So you put the number in first. So we're going to put 16.5 in there first, and then we're going to hit this button. Okay, so you see it the same on the scientific calculator that we have for Desmos that we attached. Now onto this, we have 16.5 cubed. We end up getting that is 4,492.125. Okay, so I want to first, I'm going to multiply the top. So it's almost as if this 3 is dividing the whole thing. I'm going to multiply this by 4. I get volume equals 17,968.5 pi over 3. Okay. I could hit math enter to simplify that. I just don't have a calculator here that works with that. So I'm just going to leave it as in terms of its decimal forms in this. Okay. Centimeters cubed. Now, your units for volume is always going to be cubed. So here it's centimeters cubed. Moving on to the next one. This one's surface area. So it's as if we wanted the area of the peel of the orange. I look at my formula. I have surface area is equal to 4 pi r squared. We look, we go, okay, we need the radius. Here the radius is 2.8. Remember, this is a sphere, so if that center, or that the center is in there, it doesn't matter where it goes. Forward, backwards, it's always gonna be the radius. So I have radius is equal to 2.8. So plugging that in, 4 pi, 2.8 squared. I'll square 2.8 and multiply it by 4. I get 31.36 pi. And multiplying these two together, I get 98.52 meters squared. Area, always think squared. That doesn't change. This is just surface area. It's still going to be squared. We're going to look at number 6. We start getting into hemispheres, so it's half. It's as if I cut that orange in half. Volume here is going to be 2/3 pi r cubed. So I have a diameter of 18 divided in half. You get radius, which is 9. And I'm just plugging it into my formula. This is 9 cubed. So I'm going to cube the 9, multiply it by 2. I get volume equals 1,458 pi over 3. Throw that in my calculator. So you multiply this by pi and then divide it by 3. I get 1,526.81 feet cubed. Reason it's cubed is because it's volume. Number 8, yet another hemisphere, but this time they want surface area. So I have surface area is equal to 3 pi r squared. Okay, we have a diameter is equal to 12.2. We know we want radius, so I'm just going to divide that in half. And that gives me a radius equals 6.1. 6.1. I'm going to plug that into my surface area. So surface area is equal to 3 pi, and it's 6.1 squared. 6.1 squared times 3 gives me 111.63 pi. Multiply them together, you get surface area equals 350.7 centimeters, and surface area should be squared. Let's look down to number 9. It says, find the volume of a sphere with the great circle. So remember, when we said the great circle, how you get that is cutting this in half, and you open it, and the circle that you get there, that's the great circle. So they want the volume of a sphere. So that's what we're looking at. And this is a sphere with the great area circle. So we have this sphere, okay? And I'm taking the circle inside, the great circle, I'm laying it flat. This great circle has an area equal to 201.06 inches squared. Okay, so we want volume. So let's just think about the formula there. We have 4/3 pi r cubed. Radius, I'm only given area. Now think, this is just a plain circle. It is not a sphere. This is just a circle. I took the circle inside and I put it over here. So the area of that isn't the area as in surface area. It's actual area of a circle. So we know area is equal to pi r squared. So that's how we got this. So we're going to say, well, I know area equals pi r squared. And I know my area is equal to 201.06 equals pi r squared. So I'm substituting this in for that. Let's solve. Divide each side by pi. Crosses out here. We're left with 64 on this side equals r squared. I'm going to square root. I get 8 equals r. Okay, so that gives us the radius here, but if you look, Same radius in the sphere, so we're just going to use that now in here. Okay, so next part we're going to find the volume. Volume equals 4/3 pi 8 cubed. Volume equals, we're going to square the 8, you get 512. You multiply 512 by 4, and you get 2,048 pi divided by 3, okay? And I get volume equals 2,144.66 inches cubed. That's my final answer there. Moving on to number 10. So I'm gonna make that so you can actually see it. It says the drama club wants to make a big ball from foam. Sorry, my speech is just all over the place today. From foam to hang above the stage for a play. They plan to cover the surface of the ball with metallic fabric. What is the maximum number of square meters of fabric that the club needs? Okay, so we look at this and we go, okay, they're really taking metallic and they're covering it with the fabric, and they want to be able to see how much is that if they're covering. So is that volume or is that surface area? If you think it's covering, that's got to be surface area, okay? So we're actually looking for the surface area of this sphere, which, remind you, surface area of a sphere is equal to 4 pi r squared, okay? Then we get into what are we actually given? This is the volume of the sphere. So I know volume is equal to 1.8 meters cubed. We have to work with what we have. So I'm going to take this and I'm going to go, okay, well, I know volume equals 4/3 pi r cubed. I'm going to take this and plug it in over here because we know they're equal. That's the substitution property. 1.8 equals 4/3 pi r cubed. Okay? Love solving these things. I'm going to get rid of the 4/3 first, so I'm going to multiply by its reciprocal instead of dividing by the fraction. So I multiply by its reciprocal, and I'm going to say this here leaves me with 1.35 equals, those cancel out. So I'm going to be left with pi r cubed. I'm going to divide this by pi, cancels out. Over here, I'm left with 0.429718 equals r cubed. I'm just going to keep as many decimals really as I can for right now that I think is going to affect it. So this is a r cubed. We want r. So prior to this section, if we were given something like 64 equals r squared, like one of our first problems did, so this is not relevant to this. If we had this, we would square root, okay? The thing about this is there's actually a little 2 here that we just don't write because we use it, this is just its normal, so this is the square root. And we get 8 equals, those cancel out, giving you r. So I want to show you what happens when we have something with a cubed root. So let's say we have, for example, 8 equals radius cubed. Instead of putting a square root, we're going to do a cubed root. This one you do have to write the number 3 in there. I get we don't for square root, but we just imagine it's there, okay? So over here, the cubed root and the cubed cancel out. And I'm left with the cube root of 8. That means what times what times what gives you 8 if those are all the same number. So in this case, it's going to be 2 equals r because 2 times 2 times 2 equals 8. So cubed root of 8 is equal to 2. So that's how we would get this over here. So that's what happens. So I look back over here and I go, okay, what do I have to do to get my R? I want to take the cubed root of that. It's going to be a button that looks like this. Here, that. So that's what you're going to get in your Desmos calculator, along with if you turn your phone sideways. If I'm correct, the actual graphing calculators, you actually have to hit into math first and then get it from there. But most of you are probably using the Desmos or your phone. So that's what we get here. These cancel out, leaving you with 0.755 equals radius. I just kept 2 or 3 decimals. It doesn't really matter. Let's go back into surface area. So now that we have this, I want to go into my surface area because that's really what I want. Okay, so I have surface area equals 4 pi r squared. I'm going to plug in this r into here. I get surface area equals 4 times pi times 0.755 squared. I squared this and then multiply it by 4 to get me 2.2801 pi. Now multiply it by pi. I get surface area equals 7.16 meters squared. And so I need at least 7.16 meters squared of fabric. So I need 7.16 square meters, okay?